Modern air-fuel ratio sensors sometimes can be a little bit of confusion about them, sometimes kind of hard to test. You certainly can't test amperage with them using a lab scope. You really have to check in the scan data to see what that air-fuel ratio sensor is doing and whether or not it's actually working properly. So let's go through a little bit of a description of how they work, and then we'll go through the scanner and see how to test them. Okay, so let's get into some information about how they work first. So a good place for that, if you have a tool with the guided component tests in it, that's a good place to start. So we'll go in there. It's in the fuel injection system, and there it is, first thing right there, air-fuel ratio sensor. And the first thing is always component information once we open a component. So we'll go in there and see how it works. So the sensor contains a pumping cell and a reference cell separated by a porous diffusion gap. So basically it's like two oxygen sensors smushed together in a sandwich. The purpose of the pumping cell is to let oxygen into or out of that reference cell depending on whether it's needed or not. The computer is always trying to keep that reference cell at a lambda value of 1, or stoichiometric, which would be 14.7 to 1 air-fuel ratio. Always trying to keep it at that ratio. So to do that, the ECU supplies the pumping cell with a current so that the sensor output voltage from the reference stays at a constant. So it's trying to keep that reference voltage the same. When the reference cell is lean, a positive current is used to put more oxygen out of the cell. And when the reference cell is rich, a negative current is used to put oxygen into the cell. When that reference cell is at lambda 1, there will be no current applied to that pumping cell. So the amount of current supplied is proportionate to the amount of oxygen in the exhaust gases. Now the sensor operates correctly only when it reaches a certain temperature, so these things get pretty hot pretty fast. With these newer ones, it's within 10 seconds it's hot enough to start, and it's over 1250 degrees is what it needs to be. And also to remember, output is opposite of what you'd see with a normal oxygen or a conventional oxygen sensor. Higher voltage under lean conditions and lower voltage under rich conditions, which is the opposite of how a normal oxygen sensor would work. It also reacts a lot faster to these AFR sensors, and you're usually going to see, because the signal lines are biased with about 2.9 to 3.3 volts. So when it's just sitting there, you'll see round about 2.9 to 3.3 volts. So let's go into the scanner and see what we can get on data. Now we'll go into the engine, and we'll go into data display, and I've got AF sensor data singled out right there, so we'll go in there. Okay, so I'm going to have my buddy Jim get in the car right now while we're waiting for this data to load, because he's going to need to start it up for me in a minute. Now there's a whole lot of different data going on here. We don't really need all of this, so let's pare it down a little bit and use a custom data list here. So on the Varus, we'll just hit custom, and then we'll deselect all of them. And I'm going to look for AF lambda, AF current, AF voltage, and I'd also like to see what my short-term fuel trim is doing in relation to them. So we'll pick those, go back to my list. I can graph them all up if I want to. There. Change that to the bottom there. There we go. Okay. All right, so if Jim can start it up, we can see what these things will do. So here you see there's where it started up. Roundabout idle, and the computer's trying to keep that lambda back to around 1. So right now we're looking at 1.00. And notice how the current, like it said before, there's going to be no current flowing through as long as that lambda is close to 1. And we can see also the voltage is roughly round about 3.3 volts there. So it's behaving exactly as it would tell us. So if you can blip the throttle a couple times there, and you can see how quickly that reacts there. You can see there's 3 quick jumps in succession, 3 quick jumps in succession. Everybody follows everybody else. The short-term fuel trim reacts very quickly. And this whole reason is the reason why these vehicles are so good with fuel economy and can adjust their fuel so quickly, so well, is by using those AF sensors.